Hello there, and welcome to day 67. 67 days of the 100 Days Python Programming Challenge. My name is Fumi, and the topic for today is drumrolls, Numpy. I'm excited about Numpy. Today I'll show you how you can create arrays, how you can initialize an array, how you can perform indexing and slicing, and the basic operations that can be done with arrays using Numpy. So this is day 67 of the 100 Days Python Programming Challenge, and the topic is Numpy. Let's begin. Hello, everybody, and it's day 67, 67, 6 and 7. And today I will be talking about NumPy. I don't know if you've heard about NumPy before, or this is your first time you're in log. NumPy is a Python library that is used for numerical computing. It provides high performance and multi-dimensional array and to work with them. It is useful for scientific computation and data analysis. And as usual, this is the documentation. You can check it out, check what you can do with it. There are different process and different formulas that you can use with NumPy. But today we'll go through the basics and then you can go further to research. So the first thing that you have to do is to install NumPy if you don't already have it installed in your system. And then we'll import NumPy as NP. And then we want to create arrays in Python using NumPy. So we'll create one-dimensional arrays, we'll create two-dimensional arrays, and we'll create three-dimensional array. So first, let's create a one-dimensional array so you can see NumPy at work. So to create arrays, you use the np.array. And this is the array that we want to create. It is a list of numbers. And then when I run this, we have our one-dimensional array. So creating an array is just using numpy, np as numpy that we imported, and then we have our list of arrays that we want to create. So this is just one list, so it means we want to create one dimensional array. And then if I have for two-dimensional array, let's also create for two-dimensional array. In this case, we would have two lists in our main list. So this is our two-dimensional array. So you see I have my first list that is 1, 2, 3, and then I have my second list that is 4, 5, 6, and they are in my bigger list. And then to create it, I use the same np dot array, and when I run this, I have my two-dimensional array. You can see the difference between a one-dimensional array and a two-dimensional array. Then the other thing that we will do is to create a three-dimensional array, because I said we will create 1, 2, and 3. So this is my three-dimensional array. You see, I have my list. In my first list, I have a bigger list, like a really big list, and then in that list I then have smaller list. So this is my first list, and then this is my second list. So I have multiple lists in that list, and I use my np.array, and when I run this, I have my three-dimensional array using numpy, still using np.array. So arrays can be one-dimensional, two-dimensional, or multi-dimensional, and you use the np.array. The dimension depends on how your list are, how you define your list. A single list will be more dimensional. Two lists in a big list will be a two-dimensional, but when you have multi-list, then it creates multi-dimensional arrays. So now that we have an array, what are then the attributes that we can perform? For instance, if I want to get the rows and columns of my array, I will use the array, the variable name dot shape, because I want to get the shape of the array. So if I want to get the shape of my two-dimensional array, array 2D, I will then use array 2D dot shape. And then when I run this, another thing that I can do is to determine the number of dimensions that my array has. So let's determine the number of dimensions, still using my two-dimensional Array as two dimensional. So let's see how we can get the dimension. So we have array 2D, and then we have the number n and dim. So number of the dimensions. And when I run this, we have 2 because it is a 2D array. Another thing that you can do is to determine the data types of the elements in our array. And you can see the elements that we have integers. So if I want to do the data type, I'll have array 2D. What is array 2D again? The name of my variable, and then the result should be int because my array, the elements in my array are integers. Then another thing that you might want to do is to know the total number of elements in your array. And you do that by doing array dot size. So I'll have my array 2D dot size, and this should give me the total number of elements in my array. And then there are 6. 1, 2, 3, 4, 5, 6. So we have 6 elements in my array. So this is how you can perform like different array attributes. So the next thing that I want to show you is array initialization. So imagine I want to have an array and I just want there to be zeros in my array. I want to have just zeros and I don't want to like manually have to create my list and the rest. This is how I would have my array of zeros. I'll use numpy dot zeros, and then I'm defining how many rows and how many columns I want in my array. And then if we print it, we should have a 3 by 3 array with just zeros in them. The next thing that I might want to try is also like arrays of ones. Since we've done arrays of zero, let's also have arrays of ones. So the same thing with numpy dot zeros, I would have numpy dot ones, and then I want it to be a 2 by 4 array. And then when I run this, you see we have 2 rows and then we have 4 columns. Other things that you might want to do is to determine the range of values that you want in an array. So imagine I want to have my array to start from 10 to 20, a range of 10 to 20, but then with a step of 2. So I just want even numbers. Say to start from 10 and it to take 2 steps and then it to pick 11, 12. It takes 2 steps, it picks 14, 2 steps picks 16, 2 steps picks 18, 2 steps 20, but we said range of 20, so we're skipping 20, and then it will stop at 18. So to then do this, we have the numpy dot a arrange, and you see what this is our starting point. Our starting point is 10. This is our ending point. Our ending point is 20, and this is the step that we want to take. We want to take 2 steps. So when I run this, you see we have 10, 12, 14, 16, and 18. Another array initialization that you might want to perform is evenly spaced array. So you have a starting point, you have your ending point, and then you have the number of element that you want, and you want it to be evenly spaced. So imagine your starting point is like 1 and then your ending point is like 5, and you want it to be evenly spaced 5 times. Your arrays will be 1, 2, 3, 4, 5. So let me show you how you do it. You use your line space to be able to get your evenly spaced array. You see my starting point is 0 and then my ending point is 1, and I want it to be evenly spaced. I want to have 5 elements. And then when I run this, you see it start from 0, we have 0.25, we have 0.5, we have 0.75, and then we have 1. And you can see they are evenly spaced. You see the numpy zeros and 1 create arrays of zeros and ones, and the arrange helps you generate values with a step. The line space creates evenly spaced array numbers over a range, while also you can use random to generate random arrays. So now let's generate random numbers. So this is how we'll generate random numbers, and this will be the shape of our array. We want a 2 by 3 array. So when I run this, you see we have 2 rows and then we have 3 columns. So this is how we've been able to generate random numbers in our array. The other thing that you might want to do is indexing and slicing. So if you have an array and you want to access like a row, you want to access a particular column, or you want to access a particular element in that array, that's what you would do with indexing and slicing. So this is my array. This is my 3 by 30 print array. And then when I run this, we have our three-dimensional array. And then if I want to extract elements at the 1 by 2, so I want to get the array by that. So let's access the element. So I want to access the second. So you see, element at 1 by 2. So counting this would be our index 0, this would be our index 1, and this would be our index 2. So I want to get the element at index 1 first, and then this is the first one, and then inside this one, then I want to get the index 2. So to start from 0, 1, 2, and that gives you 6. If you want to get the element here, then it should be 2 by 2. So if I change this to 2 by 2, you see we would get 9. So this is how we're able to like get elements in a particular array. Another operation that we can perform is row slicing. So if I just want to get the first row in my array, what I can just do is array, and then I want the 0 index. And then when I run this, we get our first row, which is 1, 2, 3. If I want to try for like the second index and then I run this, we get our second index. So this is how you get a specific row in your array by using the index number. Other things that you can do is column slicing. No, we've done row and then this is column. So you see this is row and this part is the column. So if you want to perform like column slicing, let's get our second column, which would be at index 1. And then if I run this, we get our second column. So we use square brackets to access element, and we use this colon to specify the range for slicing the rows and then the column. So there are basic operations that you can perform with an array. You can perform multiplication, you can perform addition, you can do scalar operations, and you can do comparisons. So let's have our two arrays that we would use for our basic operation. So I want to perform addition. I want to add array 1 and array 2. I know if I add it, 1 plus 4 is 5, 2 plus 5 is 7, and 3 plus 6 is 9. And I also want to perform multiplication. 1 times 4, 4, 2 times 5, 10, 3 times 6, that is 18. So let's do element-wise operation. Let's perform addition and multiplication of our arrays. And when I do this, you see we have our addition and then we have our multiplication. We can also do something called a scalar multiplication, a scalar operation, that is multiplying a particular array by a number. So I can choose to multiply my array 1 by 2 or choose to multiply my array 2 by any number that I so please. So that is a scalar operation. So if I want to multiply my array 1 by 2 and then I run this, we have 2, 4, and 6 because that is the scalar operation. And then you can also perform comparisons with your array. You can compare each element in your array if they are greater than a particular number or not. So let me show you how you can do it, or if they are less than, not just greater than. So I want to check if my array 1, if it is greater than 2. We see that 1 is not greater than 2, we see that 2 is not greater than 2, and we see that 3 is greater than 2. So I should have false, false, true. And then when I run this, you see we get false, false, true. And these are some of the operations that you can perform. You can perform addition, multiplication, scalar operations, and comparison. There are so many others. As I said, always check the documentation so you can learn more. And then let's do aggregation. What do I mean by aggregation? You want to find the sum, you want to find the mean, you want to find the median, you want to find the standard deviation, and you want to find the max value. And how do you do that? For sum, we'll use the np.sum. For mean, np.mean. For median, np.median. For standard deviation, np.std, not the std you're thinking of. And for the max, np.max. And then when this is my array, and this is all we have here. And when I run this, We have our sum, which is the sum of the elements here, our mean value, which is the mean, our median is this, our standard deviation is this, and this is our max value. So we've talked a lot today about the NumPy, the operations that can be performed with NumPy. We're able to find our array attributes. We're able to initialize our arrays. We're able to do indexing and slicing with our arrays. And we're able to also do basic operations and aggregations. That is it for today's video. Tomorrow, we'll talk more about array. We'll talk about reshaping array. We'll talk about broadcasting, matrix multiplication, sorting and stacking and splitting, and so on and so forth. So you do not want to miss day 68, where we continue our discussion on arrays. That is it for this video. Do not forget to subscribe, to like, and leave a comment. Let me know if you have any questions. And as always, the link to the Jupyter Notebook is in the description. See you tomorrow.